Um, well, welcome to the Tech Talk. Today we're going to talk about reporting, transportation reporting, and its complexities. We're going to talk about a product that we have called the Transportation Intelligence Gateway and how we've designed and built this tool to address some of the more complex features required from transportation reporting. So during this 30 minutes, we're going to start off just by acknowledging the complexity of transportation reporting and why it's different from other types of reporting, how the TIG can help simplify some of those complexities. We'll talk about during the presentation as I go through these slides. I'll bring in examples from several of the projects we've done around the world, really. HPMS, we have TIG in use for HPMS in several of our accounts. It actually was built in cooperation with the state of Oregon to address HPMS specifically. So it was architected for HPMS, and during our process of both specifying the functional requirements and then constructing it, we made it more general to handle any type of complex reporting. We also worked with our colleagues in India and used TIG for HDM4 World Bank reporting. And we have several ongoing user projects, again, across the world. RMS in Australia, BCC in Australia, Oregon, the UK, and other places. We'll talk about what we're going to be doing with the TIG in the future. And of course, you can type in your questions at any time. All right, so to start off, as you all know, being transportation experts, the process of reporting can be quite complex. And there are several reasons for that. Firstly, it's never the case where you have a simple system that tracks all of your data. It is far more common to have a linear referencing system that has constraints around how assets are located. It has constraints around how networks are defined. And in addition to your LRS system, you have data silos spread throughout the organization, some for pavement, some for assets like guardrails and signs, structures like bridges, traffic like AADP, and various other data sets. So the task of a reporting system is to be able to reach into each of these systems and produce comprehensive reports. For those of you who are involved in your biannual transportation reporting, your planning process, you know this could be quite a complex task. And so our reporting system that we built, called the TIG, takes into account some of these complexities, and I'll show you how we've addressed them. All right, and again, from your reporting system, we would most of our accounts want both tabular and spatial output. So some of the challenges, just to summarize, that we typically in our accounts, we see asset management systems plus a whole bunch of standalone data silos. There are multiple data owners, can employ multiple linear referencing methods. There's XY, root offset, milepost offset, to name a few. Multiple technologies, some are Oracle shops, some are SQL Server. A lot of our accounts have data in spreadsheets or Access databases. And what we find over time is that at each account, there's that one person who seems to know everything about the system. And everyone seems, in a lot of cases, to be beholden to that one individual. And so part of our design is to spread that ability out to lower the level of expertise required to do some of these complex reports. All right, data structures that you deal with could, in many cases, be inflexible, and again, it all leads to a very costly system, one that's very difficult to systematize. Right. So, in terms of linear analysis, one of the foundational technologies that a reporting system must possess is the ability to dynamically segment data. And by dynamic segmentation, what I mean is it needs to be able to reach into each of these systems, regardless of where they're located, regardless of what linear referencing method they employ, and pull all that data together dynamically segment it, which means basically chop it into chunks where all of the attributes you're interested in are identical within that chunk, so that you can then go ahead and do your analysis across those chunks or those segments. And that needs to be done dynamically. And again, so as a foundational technology or a function within a reporting system, it has to possess this ability to dynamically segment. All right. And again, that gives you the ability to drive new information through the combination, comparisons, and processing of various values. If you look at a system like HTM4, the very first task in HTM4 is to create pavement sections where all the attributes of pavement are identical across that section of road. And then after you've created those sections, then you do analysis on those sections to find out what other attributes are there. So it's a two-step process. The data is not stored as section data, so you need to be able to derive that, and the reporting system should be able to handle that with ease. All right, and again, reporting across asset classes, different modes of transport, and temporal reporting, also very important. Year-to-year analysis is quite important, and again, I'll show you how we built that in. So it's really just a matter of entering dates. One of the things that is most interesting to the pavement folks is what's happened to the safety figures now that we've repaved a section of road, or now that we've taken a corner out. And in order to do that type of analysis, you have to have your before data and your after data. And so reporting in a temporal manner is actually quite important. Right? And again, the output has to be distributable, it has to be logical, and needs to be spatial as well. So with the TIG, this is an example of this same diagram that I had just shown, where we have multiple data sets. And if you notice in these data sets, we have traffic count data, we have repaving and mowing projects, guardrail assets, bridges, pavement types, and pavement condition. And if you notice also the structures, these bridges are located by XY. These four assets are located with a route offset. Pavement condition is also route offset, but if you notice, it's all route 90. It's just they're indicated differently. They come from different systems. And so the reporting system has to be able to reach into each of these systems, do that conversion, and then produce a dynamically segmented set of data that you can then analyze. All right, and so this is what the dynamically segmented view of this data would be if all of these attributes were considered. And if you notice, the chunks match up to the breaks across all of these assets. And so the highlighted rows in green are all pavement sections or all route sections where the pavement condition is poor and the traffic volume is above 1750. All right, that information comes from various systems, but again, it's all pulled into the same, dynamically pulled into the same logical table where you can do that type of analysis. All right, so a reporting system should be able to reach into any connected transportation data system. Generally speaking, a reporting system should be able to handle all reporting functions. Your asset management system and your linear referencing system should be optimized for transaction processing, not reporting. The reporting system should handle the reporting bit. And so what one should be free from having to do is to dynamically segment your data or segment your data, hard code segmentation in your linear referencing system, or hard code segmentation into your asset system. Those functions of adding assets and maintaining road networks should be natural to that process, and let the reporting system handle the segmentation of that data and the analysis of that data. All right, so again, these are some of the things that we considered when building this product, that we had to have the ability to reach into any connected transportation data system. All right, handle conversions between different linear referencing methods, also units of measure. A lot of our Canadian accounts measure their roads in kilometers, and their assets are located by meters. And so you have to just do a simple conversion for that. All right, dynamic segmentation is based on user-specified criteria, not hard-coded beforehand. That's not dynamic. That would be static segmentation. So your dynamic segmentation should allow you to go into your reporting application and not know what data you want out before you start. Just if you're in pavement, well, it's someone just asked you a question about pavement. Go ahead and query your pavement systems with that query, having it where you can develop a process for doing so that you get FFT. All right. Processing options in the reporting system. Again, all of your aggregates should be included automatically. That's min, max, count, sum, average, and things along those lines. Your analytics, your LWAs, and your most common MCDs, the most common values. And HPMS terms, that length weighted average and predominance. And then any custom formulas that you've developed, you should be able to easily incorporate those into your reporting system. Right. Roll-up capabilities, that's your post-analysis data consolidation. If once you do all of your analysis, you end up with data that's segmented, and the type of analysis you've done allows you to roll those rows of data up, consolidate them. Well, that again should be a natural part of the application and require no programming. And once you've defined a report or a data extract, again, you should be able to schedule that. Right? And once again, output options have to be varied, including maps and logical reports. Right. So this is another view of that same diagram, again, focused on the reporting system. So the Transportation Intelligence Gateway, it is a reporting system. What it does is it produces all the data required for the display and distribution of transportation data. And what you can do within the TIG is access all your asset data, all your data silos, and any network LRS data. And when I say any, the reason that's enabled within TIG is because we use what we call an abstraction layer, where you define access to these things separately, so that by the time a user enters the TIG, all of those connections are handled behind the scenes. And the TIG is smart enough to know if one of these systems is XY data, or one of the systems is route mile point, or if they come from different sources. It knows behind the scenes how to join that data together. It's nothing that a user would have to try to figure out. And so once you have that reach established into these various data sets, then within the TIG, again, you have the ability to extract values, to do all of your mathematics as well, and your roll-ups. Okay, and the output of which you have an option of doing just logical data output or intelligent maps, which is basically this data, the table data embedded in the map features. Okay, so as I mentioned, we built the TIG in cooperation with the state of Oregon. They came to us and said, hey, we need to simplify our HPMS process. What can you do to help? And TIG was the answer to that. And so we essentially started with a blank piece of paper and said, all right, what are the most important things that are required for the satisfaction of the HPMS, ever-changing HPMS requirements? HPMS, for those of you who aren't from the United States, is a U.S. federal reporting requirement. Each state has to submit a report. It's a 69-part report that indicates the condition of the road system for each state. So it's similar to HCM4, although it doesn't simply focus or just focus on pavement. It focuses on a lot of different criteria. Right. And so what we did, we went ahead and said, okay, it has to be web-based. We can't be bothered with client installs. There could be people out in remote offices who will need to know information, need to supply information. So web-based was the way we went with it. We need to be able to access data from any source. We need to accommodate multiple LRMs. We need to remove the dependency on custom programming. Like most states, Oregon had that collection of people who go crazy for 3 months each year trying to get this report out the door. And a lot of the functions that they perform are basically getting all the custom programming that they've built lined up to run against different data sets that they import. And so we need to make that a whole lot simpler. We've talked about dynamic segmentation. Everything had to be spatially enabled. We needed to roll up data along a route. Again, that's combining contiguous identical sections. And we need to roll up data along any criteria. So we can produce in TIG summary information by district, by county, by state, or by any other group or collection that you identify. It isn't just simply a route-based reporting system. Right? Fully documented upgrade protections. Again, if you're using the Transportation Intelligence Gateway with Bentley's LRS or asset management system, then it will be guaranteed to work. And if you're not using it against the LRS, Bentley's LRS or asset management system, then we guarantee that extracts that work in one version will work in all versions of TIG. Right? And so when we built this, we started off with, all right, what do we need for HPMS? We took those requirements and then we added more requirements to it to make it more general purpose. So we took out the dependency on HPMS and added capabilities to make it much more generic. Right? So right now with the TIG, you can use it for really complex extracts like HDM4 or HPMS, or even simpler ones. Like show me all the speed zones. What are the speed zones along our state routes? Something very simple like that. All right, so this is what it looks like when you log on. If you notice, what we have are on the left-hand side is all the extract definitions. Just excuse me for 1 second. We have all of our extract definitions along the left. They are organized into catalogs. And so in this HPMS work in progress HPMS catalog, we have 9 different extract definitions. All right, and you can have any number of catalogs, and in each catalog you'd have any number of extracts. Each of these can be assigned by user and locked by user, so that only the originator can make modifications to it. And to the right, this is the work area, which just starts off with a intro blurb, and there's a copyright and user ID. So the organization of an extract, all right, it's one of the key distinguishing traits of TIG. And what we have is a 4-part extract. The first part is just summary information. You give the catalog a name. You give it some other information, which I'll talk about a bit later. But really, it's what is this? What are you attempting to do here? You do have the ability to enter 4,000 character description of what you're doing to document the extracts. Again, so one person can build the extract, multiple people can run it. You give it some location information. Against what LRS or LRM do you want the results displayed? All right, so that's a pick list. You just pick from a list of LRMs that are available at TIG, which are available from your LRS, or ones that you can construct on the fly. So TIG gives you the ability to construct an LRS on the fly, and I'll explain why that's important a bit later. So the attribute sets. This answers the question, well, what do you want to report on? So if you want speed zones or functional class or ownership, well, that you supply all that information in an attribute set. All right, you can give that attribute set a name, and then you can have multiple attribute sets. You can have a collection of them in one extract. So in HPMS, which is a 69-part extract, or in HDM4, which has over 100 different attributes that have to be reported, you can define an attribute set for each grouping of output. So in HPMS, that's each data item. So you would have 69 attribute sets in your HPMS extract. which is what Oregon and Connecticut and Kentucky have. And so what we can do with an attribute set is you can decide whether to include that attribute set in the output or simply use it for calculations. So technically speaking, the Oregon HPMS extract, which is simply executed by the push of a button now, they call it their easy button, it goes through each of the 69 data items and writes output into submit sections table. And what they have in addition to those 69, they have 30 other extract attribute sets in that collection that are simply used for calculations. So if you have to, for instance, if you need to know the minimum vertical clearance for a bridge, for every road under a bridge, you need one number, but you have 5 roads, you can create an attribute set that summarizes that by bridge ID, not included in the output, but include that the calculation results in a subsequent attribute set. So, so again, it allows you to build really complicated, really complex extracts if you so choose, or you can keep it quite simple. All right, and then for spatial information, with a click of a button, you are going to produce a map alongside the table of output. It's a spatially enabled table that gets output. All right, and so this is an extract definition. The output of this allows you to enter, make an entry into your abstraction layer so you can use it as an asset without having to clog up your asset management system or your linear referencing system. So if you have 4 or 5 different reports that you have to produce and they all have the same base information, like speed zone or traffic volume or pavement condition, you can produce one extract that has those 3 attributes in it and then use the results of that extract and any number of other extracts. That way you know that you're reporting from that same base of information. Okay, so a simple extract example. This, if you're familiar with HPMS, there's a catalog requirement where you have to produce route shapes. And what that simply is a listing of all your routes and their shape. And this is what that would look like conceptually. So your summary information, give it a name called HPMS route shapes. Your location information, it's a state route system. For now, it's a state route system. There's one attribute set where you give it the route name and the route type. And what it does is you've identified where to get that information. It produces that, and the spatial information, it'll generate the geometry for it. So this is very simple. There are more complex examples like with this one, where submit sections. Again, your state route system is the location information. That's where you want, that's the data you want to report from. And so this has 4 different attribute sets in the collection. All right, the functional system you're going to include in the output. That's where you give the functional system code in its description. Urban-rural indicator, that's also included. Stop sign count, you're going to exclude that because all you're going to do is count them in this one. And then in the next attributes, like your turn lanes, which you include, you're going to use the results of this and you're going to add to it the left turn lanes as well. All right, so that's a more complex example without going through the screens for it, but that conceptually is what it looks like. And for this particular extract, you're not going to have any spatial, you're not interested in spatial data for it. Okay, so again, just to review, so we have in this abstraction layer pointers to your linear referencing system, and then the diagram I used earlier, you have traffic, inventory, geometrics, your routes, your special networks, and also pointers to extract results. And so within TIG, you have all these menu-driven analytic capabilities, the output of which can be maps, can be logical data, or in addition to those things, an entry into your abstraction layer. All right. Okay, so this is what I'm going to do is just go through a few of the for the next few slides, a few of the forms. And On the summary information, let's start with that. So I've given this a name. I've called it HPMS submittal. You give it an output table name. All of the results will be stored in this table. If you select spatial data, this will be a spatially enabled table, which you can display in any mapping system, whether it be open source or Esri or whatnot. You get to specify a catalog. Each catalog is associated with a schema, so you can organize your data by schema if you want. And here's your description. You can have up to 4,000 characters here. And then it lists all the fields that are out in the output where you can change the type and size. You can order the columns left to right, and you can index the report order of them. It tells you how often each of these are used in the extract. And so there are two features here that are important. That for temporal reporting, you can specify a date here, and what that will do is that'll run the report as of that date. And if you're using Bentley's linear referencing system and asset management system, everything is date tracked. Or if you're using any LRS or asset management system where the information is date tracked, you can supply a date here, and it's going to set the clock for those systems to that date and then run the report. So it's going to exclude all changes to the system after that date. So you can produce an extract as of 2 years ago, produce another one as of a year ago, and then compare the two. And then, so that will give you your year-to-year comparison. This second option here, it defaults to running every attribute set in your attribute set collection. For really complex systems that have 100 or so attribute sets, you can run your extract with just one attribute set, and not the whole collection. So if you're doing HDM4 and you want to just see part of your results, because that's the part you happen to be doing testing on, you can run the extract just for that part. You don't have to sit and wait. If it's a really complex multi-hour process, you don't have to run through that the whole time. Location information. So again, you can just say, in this case, this is Connecticut data, the state root system. This will automatically populate these first four fields in green. All right, so it knows that the state root system, there's a root ID begin endpoint. This cardinality is a special option used for generating spatial data. It's not included. But these are defined at system configuration. And the user has entered a few additional fields and put formulas in for them. All right, so again, all of the information will be pulled from the state root system. So that information will be limited to the state root system. This drop-down list, and again, this is Connecticut's data. They have two root systems in their LRS. They have a state root system and a local road system. In TIG, you can create. I mentioned this earlier. You can create any other network type on the fly. And so what they've done is they've created a network type that combines those two. So it's their all roads network. They can also create a custom route system for primary route. So if you have two different routes that pass over the same point, you can tell TIG which one you want to report the assets against. Okay, and you have the ability to limit your state route system, in this case, to a particular road or a particular town or whatever criteria are available. All right. So stop sign counts. This is your step 3. This is your attribute set collection. This is one attribute set. I called it stop sign counts. And what I did is I said, all right, count the assembly IDs in your sign panels over your HPMS sample section. An HPMS sample section, again, if you're not from the United States, HPMS sample section is just a linear group. It's a section of road against which one must report data to the federal government. All right, and there's a whole science around placing these throughout your network. Okay, to get a representative sample. And in this case, I'm only going to report on stop signs. So it requires no programming. You just all menu driven. Quite simple. So if I just take a step back, what I'm going to do is show you what's in this drop down, in this one, and so on and so forth, just to show you how that's assembled. All right. So under your actions, for any of your selections. You can just report the attribute value if you wish. You can create a function based on that attribute value or a function based on any of the attributes that you've selected. You can do all of your aggregate, sum, count, min, max, average, your analytics, length, weighted average, most common value over a range. So those are the options that you have. This asset or group ID, this is a long list of everything that the TIG can see. This is, again, Connecticut. You can see from the elevator bar here, it's quite a long list. In this particular case, all the blue items are point items and all the black ones are linear. And so one needs only select from the asset that you have. Doesn't matter where it's stored, what system it's in, doesn't matter if it's in asset management system A or if it's out in a spreadsheet somewhere. And once you select one, then you have a list of all of the attributes in that of that asset. All right, you get to decide whether or not you want to include this in this attribute set or just use it for a calculation. Put the calculation in, you can give it an output column. All right, so this is another example where I'm just pulling out values, and I want the speed limit, the functional class, the county, and the town. All right, and I only want that for Hartford and Middlesex. So again, it's as fast as you can click these things. That's how long it takes to generate this data. If you want spatial data, click on any of these options. If you don't, you say I don't want spatial output, or you do route mile point. It automatically fills these in. You notice you can create a super load, which is Bentley's oversized, overweight vehicle permitting application. It can automatically generate the linear coordinate file for that too. All right, so if you want to incorporate information from outside of the Bentley environment, you can create what are called custom objects. This is a list of custom objects here. Again, this is Connecticut. You can see from the elevator bar, they have nearly 100 of them. And essentially, you just fill this form out. Just says, okay, where is the data and how is it located? And once you fill this form out, then this entry appears on that asset list, and the system will handle all the connections behind the scenes. For your route system, this is the form one would use for custom routes. If you want to combine routes, if you want to limit a route system, or just create one for a primary route, you can do that. Again, once you fill this form out, then this entry will appear in your step 2 location information. So some special features, consolidate. That's the feature that allows you to roll data up according to any criteria. You just put a column in here, you put a formula in. If it evaluates to 1, this will get rolled up. If it evaluates to 0, it won't. So the way one would use this, in this example, is I want to calculate the average AADT over an entire town. I can do that, and what my consolidate says is essentially for every row, take one town. And because I've calculated the average by town, I only want one row of output, and it'll go ahead and do that. All right, it disregards the route mile point offsets when it does this roll up. Max length, that's an option used mostly for either safety or pavement reporting, where you can specify, I dynamically segment the data, but make the segments no greater than a maximum length. And oftentimes that's a 1/10 of a mile. So basically you take your entire network and chop it into 1/10 of a mile or 100th of a mile pieces, all right, that are used for various pavement systems. So the future, we're going to be integrating this with the LRS, the AssetWise linear referencing system. So rather than saying step 2 location information, select a route, you just draw a polygon. Say, all right, I want that area, report on that. And also all of the results are automatically listed here in your legend, so you can display them. You can do that now. So you produce a TIG extract, you can go into the LRS. It's a 2-step process of going into your active layers and then picking out the table. And then it will appear on your legend, so you can see your results on the map. And in the future, we're just going to make that automatic. Also, this is the execution group functionality. Oftentimes, if you want to do something complex, you have to run a few 2 or 3 extracts, one or two for preparing data, and then doing your analysis. And so you can go ahead and run your extracts. Like so in this example here, the first extract converts your data from XY to the LRM you're interested in. It cookie cuts your data by county. It does your pavement analysis and then summarizes it. And so those are the 4 different extracts. They're run as one set. It's run monthly, and it's just the results are distributed to these folders. So in summary, transportation reporting is quite complex, and I think we've built a tool here that handles that complexity, but also allows you to do things that are less complex as well. So again, like I said, to start off, it's critical to preserve the integrity of each transportation asset system of record without forcing reporting requirements into it. I know a lot of systems out there force you to put assets on a particular route. So if you have concurrent routes, it's nearly impossible to report on both or on the other route. And so again, that's something that we can handle fairly easily. We do have dynamic segmentation. Again, all of the procedures that are used to execute a dynamic segmentation effort are visible from within the app, so you can actually see what it's doing. Reach, most important characteristic, has to be able. You need access to the data. We have the capabilities to do all of the important things that transportation folks are interested in. TIG continues to be modified according to the input that we receive from the user community, and so that's an ongoing process. It's been in use actually in Oregon for 8 years, and around the world now that is publicly released over 5 years ago. If you'd like to see how we can use TIG in your environment, we'd be happy to set up a proof of concept. Okay. Any questions?